Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Tasni binti Abdul Latif with matrix number A22SC0335. I am a student from Department of Mathematical Science, Faculty of Science, University Technology Malaysia. Today, I will be presenting the relation of the volume and conductivity of the first order polarization tensor. For the introduction part, the first order polarization tensor PT serves as mathematical framework to describe how spherical objects respond to external electromagnetic field based on their shape, size, and conductivity. In astronomic material such as spheroid, this response varies of direction due to geometry and the material properties. This research focus on examining the relationship between the volume and conductivity of spheroids on how factors influence to the first order PT. Such understanding has significant implications in applications like electromagnetic sensing and medical imaging, where changes in conductivity and volume, for example in detecting tumor, play a crucial role. By analyzing this relationship, the behavior of spherical objects under electromagnetic influence can be better categorized for use in science and engineering contexts. The objective of this study are to derive the mathematical equation relation between the volume and the conductivity of the first order polarization tensor. Second, to analyze the mathematical relationship between the volume and the conductivity of spheroid based on the first order polarization tensor. The last one, to develop the MATLAB GUI to find B volume when K, the conductivity is fixed, and to find the conductivity when the volume B is fixed. For the significance of the research, this research is crucial as it provides deeper theoretical understanding on how the volume of the spheroid and the conductivity of the material can influence the first order polarization tensor. This might contribute to a new knowledge in theoretical study on improvising the material characterizations. The study can also be useful references in the future for using the PT in any related application, especially on fixing the volume and the conductivity. The literature review. The first order PT can be determined in the geometry, and the conductivity of B are known by using the explicit formula given in 1. Consequently, the first order PT representing the permutation due to the presence of volume is called as the first order polarization for the volume. Generally, the first order of PT can be computed by numerically solving integral equations. The analysis demonstrated that changes in conductivity affect the distribution of the electric field within the object, while volume impacts the overall strength of the polarization response. These findings provide a better understanding on how geometrical and physical properties of spheroid contribute to electromagnetic behavior, which is essential in application. The research methodology. The research methodology conducted by having the literature review for the first order polarization tensor for spheroids. Second, review and develop the deeper understanding for the depolarization factor for spheroid. Third one, mathematical for fixing volume B and conductivity K. Fourth, development the GUI method for stimulation the relation between conductivity B and conductivity K and volume B. Finally, the thesis writing, FYP presentation, and submissions. As we can see from the poster, this is the preliminary result. Okay, we got two cases here. First case are with fixing the conductivity. So from here, if what happened to the volume B if K approaches to infinity, here we will get M1, M2 over 2M1 plus M2. This can interpret by as when K, the conductivity, becomes very large and the volume approach a finite constant, volume depends on M1 and M2. The volume can grow without bound, it's stabilized at specific value. Okay, so we will go to the second case for the fixed value B. From here, we will get the expression that when B approaches to infinity, we can factor out the numerators and denominator, which imply the equation to become K naught tends to 1. Since when B, the volume, tends to infinity, K tends to 1, you can describe that the volume of B getting bigger, the volume of K get closer to 1. K stabilized, the conductivity stabilized around 1. System reached the limiting characteristic where K no longer significantly with the further increases in B, which is the volume.